So up to this point, we understand NFTs, we've deployed a simple NFT, and now we're gonna deploy a real sick NFT. I even deployed a version of this guy to the NFT market. I really liked the pug, so I kept the pug, and I didn't want that to be random, but I gave it some stats. And again, if you want to learn how to do the IPS image portion of this, leave a comment, leave a note, or just go check out that Dungeons & Dragons blog that we made before. In this video, we're going to create a cryptographically scarce NFT by delivering it with a cryptographically proven random number with the Chainlink VRF. This is an advanced NFT, and we can use this framework of creating attributes for building entire worlds out of these NFTs. Have fun, guys. We can go ahead and look at the advanced contract. So now this one's a little bit longer and involves getting a random number into your NFT. Now, why is that so awesome? Well, because you can create cryptographically scarce NFTs by having a random number. If you depend on a random number to depend on the outcome of your NFT, that automatically creates scarcity, makes kind of this game about it, which is really cool. There's a lot more to do here, so let's kill it and walk through it. What we're gonna be doing on this one is we're gonna create a random dog that has a random breed. So the breed is random. And this is obviously really cool because you can use kind of the breeds on chain to do, to maybe do some breeding or do some really cool stuff. So this can be really exciting because we're gonna get a verifiably random breed of a dog. We are gonna cheat a little bit. We're gonna make it just out of 3 breeds, but it's still gonna be random nonetheless. So let's do it. So same thing, Pragma Solidity, 0.6.6. We're going to import Openzepplin again, and we're also going to import some Chainlink code. This is what's going to allow us to create that random number. This is what's going to allow us to create this scarce NFT. Let's go ahead and create our contract. We're going to call this contract advanced collectible. And we're going to say it is ERC 721, and it is VRF consumer base. Now this VRF consumer base, again, this is how we're getting the random number. Obviously this part should look a little bit familiar. Now same thing, we're gonna get UN256 public tokenCounter. And we're gonna use what's called an enum now. And this is basically like an either or of Solidity. You'll see what I mean in a second. So we're gonna say enum breed of a pug, Shiba Inu, or Saint Bernard. So this is saying, hey, we have this either or thing where a 0 means pug, a 1 means Shiba Inu, and a 2 means Bernard. So this is what this breed means, and it's kind of just a way to write what we mean when we say 0, when we say 1, when we say 2. Now we're gonna have to add a couple other things here, but I'm gonna skip over them for now because mentally it doesn't make sense to add them quite yet. So now we're going to create our, but I will add these 3 because they're needed for the random number. So to get a random number, we need key hash fee random result. For those of you who are unfamiliar with working with the Chainlink VRF, link in the description to check it out. So let's make our constructor. So we're going to make a constructor, and this is going to take some different pieces for the Chainlink VRF. So we need the VRF coordinator. We need the address of the link token. And then we need the bytes 32 key hash. This is what we're taking as input parameters. Again, the reason we need this VRF coordinator is this is the contract that's actually going to be cryptographically checking that the number we're getting is truly random. The address of the link token, because we're working with an oracle, and again, link in the description to learn why we actually need to work with an oracle to get provably, truly cryptographically random numbers. This is what we're paying for the oracle gas, is going to be the link token. And then the key hash is what we're using to identify the proper oracle. So that's the key hash is for. And it's going to be the key hash is a main piece of why we can get a truly random number and a truly random dog breed here. So, actually, excuse me, this doesn't need this yet. Constructor public, VR, and now, again, because we're importing the the VRF consumer base, we actually need to pass that, the VRF coordinator, and we need to pass it the link token. Those are the parameters that it takes. And we get to pass in the ERC 721, same as last time, and we're going to call it doggy and dog. So same thing. So remember, we're doing this, and we can even break this out to make it look nicer. We're doing these here because these are being imported in. These are that inheritance. These are being inherited. So we're grabbing those constructors there. So once we do that, again, we're going to set the token counter equal to 0 just to start it out. And then we are just going to set this key hash and the fee. And again, we just need these for working with the Chainlink Oracle here. So times 10. So when working with the oracles, you need to pay an oracle gas, same as doing logic. You have to pay transaction gas. When working with oracles, you have to pay oracle gas. So we're just the fee on this is just 0.1 link. So we're going to be paying 0.1 link when we work with. Now, same thing. We got to create that function create collectible. However, this is going to be a little bit different because again, since we're working with Oracle, we have to send a request out, and then we actually have to define our callback, our fulfill to return it. So we actually have to wait for that Oracle to respond to us. So you're going to see we're actually going to have two functions here. We're going to have a create collectible function and then a fulfill randomness function. So, and you'll see what I mean in a second there. So we do function create collectible. And again, we're going to take a string memory because we don't want this to stay in storage. Token URI, which we're just going to kind of dump for now. But if you wanted to add something in here, like that Chainlink D&D one, you absolutely can. And then we also need to give a uint256 user-provided-seed. This seed combined with the key hash is what the VRF uses to cryptographically guarantee that the number is random. So it needs basically like a kicking off point to get it started for knowing what the randomness actually is. Oh, excuse me. And this is again going to be public returns bytes 32. Let's do this. Now, what we're going to do right away is actually we're going to request randomness. So bytes 32, we're going to get that random number to get for that random breed. Request ID equals request randomness, key hash, fee, user provided seed. And what we're going to do is this request randomness function is actually imported from the VRF consumer base. So this is what we're doing to kick off the randomness. We're saying, hey, Oracle, can you get us a random number, please? And we pass it the key hash and the fee and the user provided seed. The key hash plus the user provided seed are what it uses to cryptographically prove that it's random. The fee, obviously, is the link fee that we want to pay it. So this is great. We're kicking off a request randomness. And then in that fulfill function, fulfill randomness, this is what the Oracle actually calls back to give us the random number back. So fulfill randomness, and it takes a byte 32, request ID, and a uint256 random number. So it actually responds by inputting the request ID back in this fulfill. It calls this fulfill randomness function, and it sends the request ID and the random number to here. And this is actually an internal override function, and that's actually how it stays safe and secure. So we're getting our random function, or our random number from being kicked off here. We're going to fulfill it down below, so we get a random number, but how do we actually assign it, right? Because what we did before in our simple collector was we minted message.sender and a new item ID. So we could totally do that here, but that's not going to help us at all for creating this random number. So what do we need to do? So we actually need to make some mappings. we need to map this request to this random ID because it gives the request back and the random ID back. So we also need to map the sender to the request. So we need to do a little bit of mapping back up here. So let's go ahead and do that. So we're going to do, so first we need the sender, right? Because we need to know who the dog owner actually is. So we're going to create a mapping up here called request ID to sender. Request ID equals message.sender. And what is going to look like above is why I said and other things. We're going to make a mapping of bytes 32 to address, and this is going to be called public request ID to sender. So this mapping is going to store whenever we make a request, we want to know who that request is. Because remember, this is async. This is being called in a separate thread. It's being called back later on. So we need to know who that actually is. So that now when we get back here, we can do address owner. You know, the owner of this is going to be, or excuse me, dog owner is going to be request ID to sender request ID. So now we have the dog owner. Awesome. Then we also need the token URI. Well, how do we get the token URI? Well, we got to do another mapping. Request ID to token URI with the request ID. Because remember, it's passing that request ID back. So we need another mapping. So it's going to be mapping public. What is the mapping? Request ID to token URI. So it's going to be bytes 32 to a string. Because we're doing the request ID to the token URI. Okay. Awesome. Now what do we do? Okay, well we need that new item ID because we want to mint it. So uint 256 new item ID is going to be equal to the token counter just like before. And what we're going to do is we're going to call SafeMint now that we have the dog owner and the new item ID. And again, we can see back here, it's the same thing. SafeMint dog owner, but instead of doing message.sender, because the sender is going to be the oracle, it's that mapping setup that we did with the new item ID. So, and we can also do set token URI new item ID token URI, which for now we're dumping, but you know, if you wanted to, you could do it. Now, how do we get the breed of this dog? How do we assign the breed of this dog? This is where we want to give it an attribute. So we want to create a mapping actually called, actually I'm going to tell you what it's called, token ID to breed. So this is going to say, based off the token ID, what's the breed of that token? So I bet you can guess this is going to be a mapping of uint 256 because it's the token ID. We're doing the token ID mapped to the breed. And so since breed is an enum, we can do it like this. We can say it's mapped right to a breed. And so what we're going to do down here now is we're going to get that breed. We're going to say breed. So the instance is named breed, and it's of type breed, or you could come up with something better if that's confusing, equals breed, and we're going to get that random number mod 3. So we only have 3 types of breeds here. So we're saying we want to get a random number between 0 and 2. So that's what this mod 3 is actually going to do for us. It's going to get us a random number between 0 and 2. And that's how we're going to assign the breed. So if it's a 0, it's going to be a pub. If it's a 1, Shiba Inu. If it's 2, it's going to be a St. Bernard. Once we get the breed, then we can do request ID. Then we can do token ID to breed. of that new item ID equals breed. So now we have this mapping, and if we say, huh, what's the breed of token ID 5? We can check it with this mapping right here. Now the other thing that I'm going to do, and this is for some logging stuff, and when we run the script, it makes it like a little bit nicer. We are also going to create this request ID to token ID mapping. Mapping bytes 32, request ID to uint 256 public. Request ID to token ID, and I'm also going to make an event, and this is really just for my. You don't have to do this, but this is really for my sake here. And then create collectible. Boom. We're going to make an event here. The other thing that we didn't do actually was up here. We needed to do that request ID to token URI, request ID, sorry about this, equals the token URI. Right, because right here, request ID to token URI, we're setting that down here. So this is going to be our new, more advanced one, right? We're getting a random number to create this kind of this random dog breed, right? And you can make this, you can go insane with this. You can put 1,000 dog breeds in here. You could put no dog breeds in here and just say, hey, every time a new dog breed comes up, we'll come up, or a new number comes up, we'll come with what the breed is. But let's see if this compiles. I found you. I found you. Yes, I did mean token URI. Token URI, not token URI. Oops. Token URI, excuse me. And it compiles, which is awesome. Now again, I've already created these scripts that we're going to use here to actually deploy. You can definitely take a look at them. Just kind of briefly, this deploys that contract. This funds it with link, because again, we need link to interact with the VRF. And this one creates the collectible, and then it waits for it, and then it tells us what the breed of that of the dog is. So it's going to do it. And again, this only works on Rinkeby or Kovan, or one of the test nets, because that's where the oracles are actually watching. So we're going to run this with Brownie. Run scripts, advanced, deploy, network, Rinkeby. And this is just going to deploy that first one. I highly recommend checking out Brownie and learning some of this stuff because it's really nice. Great, and same thing. Now we're going to do Brownie, run, scripts, advanced, fund, network Kovan, or excuse me, Rinkeby. I'm so used to just doing everything on Kovan. Test. And this is going to fund that contract with link. And we can even see it if we wanted. We could go to Etherscan here. We can see that contract. Why am I so zoomed in? We can see that transaction that just took place here. Now, for the showdown, we're going to do Brownie, run advanced, or excuse me, run scripts, advanced, create collectible, network Rinkeby, again, because we're on the Rinkeby testnet. And this is going to create that collectible, get a random number, and tell us what the breed of that random dog is. So let's go ahead and run it, and we'll see what we get. I want a pug, or Shiba Inu. And this is kind of that script that create collectible. We have this switch here. It tells us, if we get a 0, it's a pug. Kind of just the same as the enum there. I want a pug. Let's get a pug. So now we've sent it. We've sent the transaction here. We've created the collectible, or we've created the request for the collectible. Now we're just waiting for the Chainlink node to respond with the random number to mint this dog and mint this breed here. Dog breed of token 0 is a pug. So the first one we bred was a pug. Yes. Woo-hoo. Although I would have liked this. I like Bernards too. I like all the dogs. I like all the dogs. Who am I kidding? This was a glorious guide on NFTs. Hope you guys learned something. Hope you guys had fun. Leave a comment down below for what you'd like to see, for what you want to see next time, for what you didn't understand. Let's go on the smart contract journey and let's build some really cool stuff. Peace.